students. So we have completed your entire concept existing in your first chapter, that is conservation laws. Okay. So here in this session, so we will solve some problems on this chapter. So we know that the linear momentum, the conservation of linear momentum, that is what it is, m1 v1 plus m2 v2 is equals to what is a constant. And also we have discussed what is the potential vector of the center of mass of that system. It may be two particles or n what n number of particles. So for that, if the system is having two particles, then we are having RCM, so which is what the positional vector of the center of mass. That is equals to what is m1 r1 plus m2 r2 divided by m1 plus m2. And next, another one is what? The velocity of center of mass. That's Vcm is equals to m1 v1 plus m2 v2 divided by what? m1 plus m2. So next thing, so that's one more important concept that we have discussed here is the conservation of your linear momentum in case of what? Variable masses. There, the velocity of the rocket at any instant of time t v is equals to v naught plus of what? Small v log of is what? M naught divided by what is a capital EMX. Okay, an angular momentum of object or a particles or a body L is equals to, so R into what is P, that is equals to what? I into omega. So where I is your what? The moment of inertia, and omega is what? The angular velocity of the object. And next, torque Q is equals to what? The moment of force, that's R into what? F. And also we have discussed about what? Work. And that work is equals to what? Force and displacement. And power, so is equals to what is F into V. That's power is equals to what? W divided by T, the rate of doing work is nothing but your what is power, or that you can write it what? Power is equals to F dot S of V. Okay. And one more thing, that's according to your which one? The work energy theorem, that is equals to what? Half m1 v1 square minus of what? Half m what is it? m1 v naught square. That's the final change in kinetic energy minus of what is the final initial kinetic energy. So that will give you what? The change in kinetic energy of that particles. So due to the applications of what? The constant of forces. Okay. So let's solve some problems on this chapter. The stage of a two-stage rocket separately weighs 300 kg and 25 kg, contains 2300 kg and 275 kg of fuels respectively. Find the final velocity that can be what? Achieved with an exhaust velocity of how much it is? 2 kilometers per second. So here, so you are having two-stage rockets. Okay, so you are having what? Two engines. Double stage rocket which contains what? Two engines. So those two rockets weighs, first one is weighing 300 kg, second one is 25 kg. The first one contains and how much it is? It's what? 2300 kg of fuel, and the second one is what? 275 kg of what is fuel respectively. So in such case, so now you have to calculate what is the final velocity that can be achieved with an exhaust velocity of how much it is? 2 kilometers per second. Okay. So therefore, m naught is 300 initial mass of the rocket. M naught plus this is m naught equals to what? 300 plus 25 plus 2300 plus 275. So the total mass of that your what initial rocket is equals to how much it is 2900 kgs. And mass, like capital M, the change in mass of the rockets is equals to so 300 plus 25 plus 275. The weight of that even what? Empty weight of that your second engine is 300 weight, 300 kgs. So the two stage rockets separately weighs 300 kg. So inside this 300 kg of tank, so you are having what 2300 kg of fuel. After burning this one, so you are getting this M. So M is equals to the mass of that rocket, weight of that rocket, first stage rocket, plus the weight of the second rocket, including its what fuel. It's 275 kg of fuel. So that's is equals to what 600 kgs. And the exhaust velocity of the gas is how much? It's 2 kilometer per second. So V of E is equals to 2 kilometer per second. Okay. So next, the initial mass of the rocket becomes this much, and whereas that your initial velocity of that rocket equals to it becomes what is a zero. Okay. So after knowing all these things, we know that formula V is equals to what? V naught plus of small v log of what is m naught divided by m. So substitute the value of V naught is 0. So small v is, it is what it is 2 kilometer per second into log of m naught is 2900 kg. Yeah, m is you are having what it is, how much it is. This one is 600 kg. So I'm inserting these values inside these equations. So the exact is what the velocity of the rocket is what v is equals to 3.15 kilometer per second. Okay. So like this, so you want to what? Calculate the final velocity of the rocket. Okay. Next one. A rocket starts from the rest with the exhaust velocity of gases, hot gases, equals to how much it is? 2 kilometer per second. Calculate the velocity attained by the rocket when its mass is reduced to what? 1 by 20 of its what initial mass. So here, so first you write what are the given things in these problems. So V naught is equals to 0. So V of E is equals to 1.2 kilometer per second. Next, calculate the what? The velocity attained by the rocket when its mass is reduced to what? 1 by 20. The M is equals to what is that mass of that rocket is reduced to what? 1 by 20. 1 by 20th of its what? Initial mass. That's why. So here I have done what? M divided by 20. 1 by 20 is the M naught is nothing but M naught by what? 20. So on putting these values, so inside this what equations? V is equals to V naught plus small v into what log of m naught divided by what m. So there, so you are getting what is your formula is V naught is 0. So V of E is 1.2 kilometer. Next log of m naught by what is you are having a main formula. What is m naught divided by what m? But here m is equals to what? So here m is equals to what? M naught divided by 20. That m naught get cancels. The 20 will goes to numerators. So you will get on putting those values. So inside that equations, so we will get the value of what? V is equals to 3.59 kilometer per second. Okay, kilometer per second. So next another one is a neutron moving with a velocity of 10 to the power minus 6 millisecond collides with a neutron at rest. After collisions, the combined mass moves with a certain velocity. Here, the neutron moving with the velocity of how much it is? 10 to the power minus 6 millisecond collides with what? Neutron at rest. After collisions, the combined mass moves with a certain velocity. Calculate the velocity. If the mass of the neutron is what? 1.6 into 10 to the power minus 27 kg, and what is mass of the neutron is 3.3 into 10 to the power minus 27 kg. So this one is a collision process. So which collision process? It is an inelastic collision. So one of the particle is at rest, and the first one is what collides with then what second particles which is at rest. After colliding, so those two particles sticks together, acts into a single mass, and moves within one velocity. So that velocity what I calculate. So therefore, by using your law of conservation of linear momentum, so you write the equation P is equals to m1 v1 plus m2 v2. That's is equals to what? So here we can put m1 plus m2 close that bracket, v is equals to what constant. This one we know it. So here, so he is asked to calculate what is the velocity of that packet. So what he is asked to calculate what the velocity if the what mass of the neutron is this much, and whereas neutron is what this much. Okay. Uh, a neutron moving with a velocity of what 10 to the power minus 6 milliseconds collides with what neutron. So here, so let us write this one here. V1 is the initial velocity of our first particle, and V2 is the second velocity of second particle, but the second particle is at rest. The total momentum before collision is equals to what? The total momentum after collision is. So that's equals to m1 plus m2 into what? V, that's equals to constant. So that's why, so you write what? V is equals to m1 v1 plus of what? m2 v2 divided by m1 plus im3. Okay. So this V is equals to m1 v1 plus m2 v2 divided by m1 plus m2. Here the value of v2 is 0. The value of your what? v2 is 0. So that you are getting what? Only m1 v1 divided by m1 plus m2. So m1 is the mass of your what? Which one? That's neutron. That's 1.67 is there. Whereas neutron is what? 3.3 into 10 to the minus 27 kg. So you would substitute these two values, and you write the velocity of your neutron, that is 10 to the power minus 6 millisecond. So on inserting these values, so your final velocity of that coexist a single mass or combined mass of your neutron and neutron is equals to how much it is? 3.3 into 10 to the power 5 millisecond is what meter per second is. Okay, meter per second is. So next, another one more example. So inside this chapter is two particles of masses 0.1 kg and 0.3 kg have positions at 2i plus 3j plus 13k meter and minus 6i plus 4j plus of 2k respectively. Find the instantaneous position of a center of mass. This is what the position of the center of mass of that system. So here, that system is having what two particles. So which are at a distance of this much, and what this much. First particle is at a distance of what this one. The positional vector of first one is this much, and whereas the second one is this much. From your what a fixed reference point or the chosen reference point. Okay, fixed points. That's why I write what small r1 or if I can write the capital R1 equals this much, and R2 is equals to minus 6i plus 4j plus of what 2j. So therefore we know that the positional vector of center of mass when that a system consisting of two particles is given by m1 r1 plus m2 r2 divided by what m1 plus m2. So here instead of writing the capital R1, so you have to write what is small r1 and r2, because here I have written what r1. Or you can change here itself capital R1 and what capital R2, no problems. So on inserting these two values, m1 is 0.1 kg, m2 is 0.3 kg, and r1 is this much, and r2 is what? This much. So you have to insert all these values. So inside these equations, so you will get what? RCM is equals to minus 69 plus 1.7j plus of what is 1.9k, so divided by we're getting what 0. 0.4. So this is the what positional vector of your center of mass of the system is. Okay. Next, another examples in that chapter is calculate the center of mass. Calculate what? The center of mass of the following system. So what is that system? A mass of 5 kg lies at a distance of what? 1 meter. A mass of 3 kg lies at a distance of what? 4 meter. And mass of 2 kg lies at a distance of what? 0 meters. So here you have to calculate that. So what is the center of mass of that system? It is what is you have to calculate which one is so velocity of center of mass or center of mass of that what system is. So the center of mass of the system is given by xcm is equals to what? This is the position vector. The position whatever I have written here, this rcm is equals to m1 r1 plus m2 r2 divided by what m1 plus m2. So for m1 plus m2 we can put what capital M, the total mass. Okay, so that also here I have written what xcm instead of rcm. So here I have written what xcm is equals to 1 by m into bracket what m1 x1 plus m2 x2 plus what m3 x3 divided by we can write m1 plus m2 plus m3 or we can write what capital M, no problem. So therefore the mass of the first object is 5 kg and it is a distance of 1 meter, and the second one is having what 3 kg and that one is at a distance of what 4 meter, and the third one is what is at what at a distance of what 0. It's exactly at the what center of your reference point. So divided by 10 is 1. Manipulating this one, so you will get what 1.7. So thus the center of mass of the system lies at distance of how much is 1.7 meters. Okay. The last one more example. So inside this chapter is two objects with the same mass move along a straight line in opposite directions. So as shown in this figure, if the velocity of the object 2 after collision, that we can write v2 dash is 5 meter per second rightward. Then what is the magnitude of the velocity of the object 1 after the collision is? Mass of each object. So is what m. It's two objects with same mass. So initially m1 and m2 is equals to what m is. So that means those two are what identical in mass. Okay. So here the given things are what the velocity of the object 1 before collision is how much it is 8. Okay, it's where it's mentioned. So the two objects with same mass moves along with a straight line opposite directions. The velocity of the two objects after collision. So here given things are what? The velocity of your object 1 before collision. So this is mentioned here. This v1 is equals to what? 8 meter per second. And v2 is equals to what? 10 meter per second before collision is. Okay. The given things is so velocity of your first object before collision is 8 meter per second, whereas the velocity of the second object after collision is what is 10 meter per second. Velocity of the object 2 after collision is how much it is. This is velocity of the object second one. This is before collisions. This one is what before collision is. Okay. So this one becomes what this one what make it correct. The velocity of the second object before collision is how much v2 is equals to 10 meter per second, and the velocity of the second object after collision is what v2 dash equals to 5 meter per second. And so we need to calculate what the velocity of the object when after collision is. Okay, the v1 dash, so you want to calculate. The collision is partially elastic. It's what partially elastic. Even though that means it may be inelastic or elastic, the momentum gets what is the total momentum is what conserved, but the kinetic energy is not conserved in both the case. Elastic kinetic energy conserved only in an elastic collision, but not in an inelastic collision. So according to your last conservation of momentum, This one is m1 v1 plus m2 v2 is equal to what? m1 v1 dash plus of what is m2 v2 dash. Here, the two objects are what identical in mass. So when you take m outside, so m1 equals to m2, that's equals to m. So you will get the equation like this: m into bracket v1 plus v2, that's equals to m1 into bracket what? v1 dash plus of what? v2 dash. So therefore, you make it cancel these two terms. So you will get what? v1 plus v2 is equals to is v1 dash plus of what is v2 dash. Okay. This is 10, 8 plus 10, that's equals to v1 dash plus of what? 5. So therefore, you are getting what? 18 equals to what? v1 dash plus of what is 5. So v1 dash is equals to 18 minus 5. So that velocity of the object 1 after collisions is how much it is? 13 meter per second. Okay. So one more last examples. So in this session is a 10-gram bullet fired at 100 meter per second collides a block of wood at rest. Mass of block is 490 grams. The collision is inelastic. So what is the speed of block and bullet after collision is? So here, when you say that the collision process is inelastic, when that your bullet hits that block, so those two masses means bullets and wood sticks together and move with some velocity. That velocity what I calculate is. Okay, that's that those two objects means bullet and uh, wooden block combined together are seized into a single mass. So here the given things are mass of bullet is m1 equals to 10 gram and speed of bullet is v1 is equals to 100 meter per second. Mass of block m2 is equals to 490 grams. And whereas that the velocity of the block vt is equals to 0 because it is at rest. The block is at what? Rest. Then by using your law of conservation of momentum, so that's m1 v1 plus m2 v2 is equals to what? m1 plus m2. So into you write what? V dash because that the collision is inelastic. So that your bullet and as well as what? Wooden block combined together and moves into a single mass. This is 10 into 100 plus mass of first one. First your what? Bullet is 10 gram and the velocity is 100 meter per second. Plus of what? The mass of the block is 490 grams into is what? 0 because it is at rest. So that you are getting what? 10 plus you are getting in this case right hand side 10 plus 490 into what? V dash. This V dash you need to what? I calculate this. So therefore 100 equals to 500. This is the 1000. 1000 plus 0 equals to what? 500 V dash. So therefore V dash is equals to 1000 divided by 500. That V dash is equals to what? 2 meter per second. After hitting on that your block, that block along with your bullet moves with the velocity of how much is 2 meter per second. Okay. We'll solve some more problems in the next sessions. Thank you.